Welcome back, awesome Algebra 1 students. In this video, we're going to discover why is it that when you have a negative exponent, you take the reciprocal of the base. So in case you were wondering, this is why. If you don't care why, then don't worry about watching this video. So the first thing that we're going to look at is we're going to look at some different powers. So what I've done here behind me, not the X-Wing, actually behind me, what? She's not in Star Wars, is a table. So what I've done with this table is I've broken it up. Sorry, the lines are a little wonky. I've broken it up into 3 columns. We have our powers, we're going to expand them as products and look at that, and then we're going to simplify them to find their actual value. And then over here, I purposely left this open because we're going to look for a pattern. Now, if you'd like to follow along with this table, feel free to do so, but don't feel like you have to. This is just informational for those of you who wanted to know. So the first thing that we're going to do is we're going to simplify the ones that we know how to simplify. So like, I know how to expand 2 to the 3rd power. 2 to the 3rd power means 2 times 2 times 2, right? Now, what is 2 times 2 times 2? Common misconception. A lot of us will want to go 2, 4, 6. That's actually adding. 2 plus 2 is 4 plus 2 is 6. 2 times 2 is 4 times 2 is 8. So 2 to the 3rd power has a value of 8, right? Surprise, I feel like everybody knew that. Let's go ahead and do 2 to the 2nd power. So 2 to the 2nd power means 2 times 2, right? Multiplying 2 by itself 2 times. 2 times 2, surprise, surprise, is 4. Okay, 2 to the 1st power. So this just means there's one factor of 2. So if you were to write this as a product, it would just be one factor of 2, which, surprise, simplifies to 2. And that's where we're going to leave it for now. We're going to look for a pattern, and then we're going to use that pattern to figure out what does 2 to the 0 power equal, because that's a whole nother conversation. And then what is it that these negative exponents actually do? So let's look for a pattern. How do I get from 8 to 4? Well, one way that I get from 8 to 4 is I subtract 4. Is that the same pattern that I used to get from 4 to 2? Just 4 minus 4 equals 2. No, so the pattern is not subtraction, right? That doesn't work. How else could I get from 8 to 4? What's the change there? What about dividing by 2? Does 8 divided by 2 equal 4? Yep. Does that pattern continue to work? Does 4 divided by 2 equal 8? Yeah. So what I always say is if a pattern works twice, chances are it's going to work again. So the pattern here is that every time I move down my table, I'm dividing by 2. Now, I actually could have told you that right here because division is the reciprocal of multiplication, meaning to undo multiplication, all you have to do is divide. And what dividing does is it takes away a factor. Notice how we had 3 factors of 2? Well, once I divide this by 2, this becomes a 1, and now I only have 2 factors of 2. In other words, this part of the product is canceled. I don't like that word, but you guys are used to it, so we'll use it. So by dividing by 2, we took away a factor. Now we only have 2 times 2. Then we divided by 2 again. We took away another factor. Now we only have 1 factor of 2. So the pattern as we're moving down this table, every single time we move down the table, we're dividing by 2. And notice there's a second pattern here. Our powers have the same base, but the exponent is decreasing by 1. Do you know what that 1 represents? That represents 1 factor of 2. So I'm taking away a factor of 2 each time. And because the opposite of multiplication is division, that dividing by 2 is taking away that factor, meaning I'm taking away 1 from this exponent. I know, it's super cool. Like, math is awesome. That's exactly what you were thinking. Okay, so again, if this pattern continues, if it happens twice, it's going to happen again. So I'm going to use the pattern to fill in the rest of the table. In fact, I'm going to start kind of with the values and then work my way into the product. So it's safe to say that then how do we get from 2 to the 1st power to 2 to the 2nd 0 power? A lot of you think that this is 0, but does 2 divided by 2 equal 0? Not last I checked. This pattern is going to continue because I'm removing another factor of 2, which means I'm dividing by 2. What is 2 divided by 2? I think you know the answer to that. 2 divided by 2 is 1. I know, crazy, right? Let's look at what happens there. When I remove a factor of 2, when I divide 2 divided by 2, guess what I'm left with? I'm left with a big 1, right? Because what's 2 divided by 2? It's 1. That's all you're doing. By removing a factor, you're dividing by 2 each time until you're left with just 1. That's all that you have, right? So anything to the 0 power is actually 1 because you've taken away all your factors, but there's always that 1 left over. All right, but we still have to deal with these negatives. The whole question is, why is it that when you have a negative exponent, you take the reciprocal of the base? Well, this pattern is going to continue. We've already talked about that. So I'm going to divide by 2 again. What is 1 divided by 2? 1 divided by 2. Let's write it out as a fraction first, right? So if I have 1 and I'm going to divide by 2, wouldn't that look like this? 1 divided by 2. Isn't that what that would look like? I just realized I used the wrong color. Oh well. Isn't that what it would be? 1. So we had 1 left here, and then we did 1 divided by 2. I don't know about you, but I see a fraction. What fraction do you see? I see 1/2. I know, crazy, right? That's 1/2, which is 1 over 2. Crazy. All right, let's use the same reciprocal again. Or not reciprocal. Let's divide by 2 again. Same pattern. Now, what is 1/2 divided by 2? This is where it gets weird, okay? What this actually does is it adds another 2 in the denominator. So now this is 1 divided by 2 2's. Let me show you what that looks like. This means 1 divided by 2 and divided by another 2. I know, crazy, right? So this means that to divide by 2 again means I'm adding another factor of 2 here, which is 1/4. Or we could write 1 over 2 squared, which is 1/4. Interesting, right? Are you starting to see a different pattern here? I hope so. All right, let's use the pattern to complete the table. What happens when we divide by 2 again? Let's see. Well, dividing by 2 again just brings another 2 into the denominator. I'm taking 1 divided by 2 times 2, and I'm just adding up another 2 in the denominator because I'm just continually dividing. So that now this is 1 divided by 2 times 2 times 2. Because all I did was divide by another 2, and division means denominator, division and denominator, right? So that would be, as a power, that would be 1 over 2 to the 3rd power, which is 1/8. This is 1 over 2 to the 1st power, which is 1/2. So what does all of this have to do with negative exponents? Well, in the last video that you watched, we talked about how negative exponents mean taking the reciprocal of the base. Well, if you look, our negative exponents are all fractions because once you get past 2 to the 0 power, which is 1, this pattern keeps continuing, and dividing by 2 means our factors of 2 that used to be in the numerator are now in the denominator. So you can see how we now have reciprocals. 2 to the -1 is equivalent to 1 over 2 to the 1. 2 to the -2 is equivalent to 1 over 2 to the 2. 2 to the -3 is equivalent to 1 over 2 to the 3rd. It's just reciprocal of the base. In fact, if you're looking, you would actually also notice that 2 to the 3rd is the reciprocal of 2 to the -3rd. Why? Look at these. These are reciprocal expressions. You have 2 times 2 times 2 in the numerator, 2 times 2 times 2 in the denominator, and 8 and 1/8 are reciprocal. 2 to the 2nd is the reciprocal of 2 to the -2nd, because 2 times 2 is the reciprocal of 1 over 2 times 2, and 4 is the reciprocal of 1/4. 2 to the 1st is the reciprocal of 2 to the -1st, because 2 to the 1st is 2, 2 to the negative first is 1/2. Those are reciprocals of each other. I know, it's totally crazy, right? We're going to look at another example, but this time when our powers start in the denominator. And we're going to just double check and make sure that this idea that the negative exponent creates a reciprocal of the base, we're going to make sure that that's still true. So here's another table already pre-filled. In this table, if you can see, I'll move it a little bit closer. We have this time, we're starting with 1 over 2 to the third power, 1 over 2 to the second power, 1 over 2 to the first, 1 over 2 to the 0, 1 over 2 to the negative 1, 1 over 2 to the negative 2, and 1 over 2 to the negative 3. So the only difference between this table and the last table is that now we're dealing with fractions. So we're gonna look for a pattern. Okay, so let's see now. So now I'm going to do the same thing that we did before, which is do the ones that we feel comfortable with. So 1 over 2 to the third power. I'm just going to expand that 2 to the third power. That means 1 over 2 times 2 times 2, right? We feel pretty confident with that. So what is 2 times 2 times 2? 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. So this has a value of 1/8. Okay, pretty cool. Let's look at the next one. 1 over 2 to the second power is just 1 over 2 times 2. That was a little bit easier. 2 times 2 is 4, so this has a value of 1/4. And then we like 2 to the first power. 2 to the first power just means 1 factor of 2, which is 1/2. Okay. Now, what is the pattern here? This is a little bit tougher than the last one. If you remember, the pattern from the last one was we were dividing by 2 each time. So we were removing a factor of 2, which means we were dividing by 2 each time. We're still removing a factor of 2, but we're removing a factor of 2 in the denominator. So that means, are you ready to have your mind blown? Each time we're moving along, we're actually dividing by 1/2. What? Because if you think about it, we're taking 2's out of the denominator. So that means we're dividing by 2's in the denominator. Now, I don't expect you to be able to divide by 1/2 mentally, but it would be important to note that dividing by 1/2 is equivalent to multiplying by 2. Like remember, dividing by a fraction, we can say is the same thing as multiplying by its reciprocal. So the pattern here is you're dividing by 1/2 because you're removing factors of 2 in the denominator, but that's the same idea as multiplying by 2. I know, it's totally crazy, right? Let's use that pattern then. And let's make sure that it's happened again. So again, I removed a factor of 2 from the denominator, which means I divided by 1/2, and now I have 2 2's in the denominator. Then I removed another factor, so that means I divided by 1/2 again to end up with only 1 2 in the denominator, which again, just remember, dividing by 1/2 is the same thing as multiplying by 2. All right, is that pattern going to continue? Yeah, if it happens twice, it's going to happen again. So we divide by 1/2 again. Okay, what is 1/2 divided by 1/2? Or in other words, if I remove that factor of 2 from the denominator, what am I left in the denominator? I'm left with 1, because 2 divided by 2 is 1. And what's 1 divided by 1? Still just 1. Anything to the 0 power, it doesn't matter if it's in the numerator or denominator, it's always 1. I know. All right, let's say that pattern is going to continue again. Now I'm going to divide by 1/2 again. Now, doing the math of 1 divided by 1/2, like, ugh, that sounds kind of not fun. So let's use our equivalent. Let's use the fact that we know it's the same thing as multiplying by 2. What is 1 times 2? That's 2. That means now that we're multiplying by 2, our 2's are going to start appearing in the numerator. Crazy, right? So now we've got a factor of 2 in the numerator. We took all of them out of the denominator, but now because we kept dividing by 1/2, which is the same thing as multiplying by 2, now they appear in the denominator, or excuse me, in the numerator. 2 over 1 is just 2, or 2 to the first power, which is just 2. All right, that pattern is going to continue again. This time I'm going to just use the equivalent because it's really difficult to think about dividing by a fraction. I get that. So we're just going to look at this as multiplying by 2, if you're okay with that. Okay, now multiplying by 2 just means I add another factor of 2 in the numerator. So this is 2 times 2 in the numerator. 2 times 2 is 2 squared, and 2 squared is 4. And then multiply by another factor of 2 just means I add another factor of 2 in the numerator. 2 times 2 times 2 in the numerator, which is 2 to the power of 3, which is 8. So what is our real pattern here? Well, again, look at the ones where you had a negative exponent. So we have -1 here, -2 here, and -3 here. They started in the denominator, but because our pattern was taking factors of 2 out of the denominator, eventually if you continue to take factors out of the denominator, they're going to move up to the numerator. Just like here, look at our last pattern. It works the same way. We were taking factors out of the numerator, which means if you continue that, they're just going to they're going to flip over. As soon as you get past 0, past this 1, it's just going to end up in the denominator. Continuing to divide means that it's going to flip at some point. It's going to end up in the denominator. Here, we started in the denominator, but it's the same idea. We were removing factors from the denominator until we got rid of all of them, and then that continued on in the numerator. So 1 over 2 to the -1 is equivalent to 2 to the first power. These are reciprocals. 1 over 2 to the -2 is equivalent to 2 to the second power. These are reciprocals. 1 over 2 to the -3 is equivalent to 2 to the third. Reciprocals. Not only that, take a look at these. These are actually reciprocals of each other. They don't look like it. They look like the same fraction, but they're not. 1 over 2 to the +3 is the reciprocal of 1 over 2 to the -3. Why? Because this has 3 2's in the denominator, this has 3 2's in the numerator, and 1/8 and 8 are reciprocals of each other. 1 over 2 squared is the reciprocal of 1 over 2 to the -2nd power. Why? Because this has 2 2's in the denominator, this has 2 2's in the numerator, and 1/4 and 4 are reciprocals of each other. 1 over 2 to the first power is the reciprocal of 1 over 2 to the -1st power. Why? Because this has a single 2 in the denominator, single 2 in the numerator, 1/2 and 2 are reciprocals of each other. So that is why, put my face in the frame, that is why we take the reciprocal of the base when you have a negative exponent. Let's go back to our X thing here as we sign off. So in case you were wondering, that's the reason why. So whenever you see a negative exponent from now on, wherever it is, think about taking those factors out of wherever they are and putting them in the opposite spot. So if they're in the numerator, you're going to take all those factors out and you're going to put them in the denominator. If they're in the denominator, I'm going to use this X thing as my fraction bar, then you take them out and you put them in the numerator. So remember this table every single time you're simplifying powers with negative exponents. All right, I hope you enjoyed it. Have a great rest of your day simplifying powers.